basically where there's issues that things go awry is that there's a problem in the original construction, so something wasn't constructed, it was weaker than we thought it was, so it prematurely collapses, and then all of a sudden the structure takes kind of a turn to one side or something like that. But I'm trying to think of course I'm gonna say this, I haven't seen Mark have a problem yet, and you know, I've been working with Mark for, let's see, almost 15 years now,
So is Mark the one who actually plunges the Wile E. Coyote?
Mark is the explosives guy, I'm just the engineering nerd behind the, what we call progressive collapse mechanism.
When you see a building, because we through this whole process of us.
Alright, I gotta go.
Deciding to do this, we looked at videos of
Pretty
buildings
cool.
that
Yeah,
didn't
he's
collapse.
smart. He knows.
Yes.
For real.
Is there more, what happens with something like that? How do you get involved in something like that?
Good question. Okay, so
Because it looked kind of scary actually when they didn't all
Yes.
come down.
Yes.
We saw one in Dallas.
yep,
Maybe it was the American Air, some building didn't completely collapse properly.
I can show you a picture on my
Yeah,
phone
well,
of
he
a
was just
silo
showing
that
me
just
one. It was,
So
somebody else
sometimes-
did it,
yeah.
and it didn't go right.
usually what'll happen when something like that happens
Do
is
you
that
get involved in that or no? Or is it
some
just-
of them we do. So if the client calls and says, okay, we want to complete, we're going to back off of this, we want to know what happened and we want to know how to solve it, then we kind of get involved in the analysis. Okay,
But
so
you don't blow it up again.
oh yeah,
You
Oh,
blow
yeah.
it up again
oh
possibly.
yes, absolutely, yeah.
That's interesting.
So it really depends on the team that you have. Some people will just go back in there and, you know, go up to the back of the structure, plant new charges and try and get it down.
Or you bring a
Or
bunch
you calculate it.
of front end,
approach,
but
yeah.
you don't necessarily take equipment at that point. Some you do.
Not
I guess,
necessarily,
so.
yeah, some, you know, depending on the type of demolition being done, so, you know, there's explosives and conventional and things of that nature.
How busy are you with all this? What's
We're very, very busy. About 1/3 of our business is demolition, which, so we've been doing it since 2006. In 2012, we kind of looked up and said, wow, we've done a lot of demolition work and there's just not a lot of people that are doing it.
Yeah.
So we decided in 2012, okay, we're gonna go and get serious about
Nice, good,
being
cool.
true demolition.
So there's enough volume of work for that then.
Oh, yeah. We were kind of the
All right,
first group
cool.
to kind of take high-end engineering and bring it to the demo side. So prior to that,
There's
demolition
some
was pretty
serious
much a
calculus in
pyramid.
this thing, man.
Yeah.
No, there's some serious
Oh,
work
yeah.
in this, so you can see that.
Yeah.
In any of the meetings I've been in where I've seen some of the prep work that's being done, man, it's crazy.
Yeah, yeah. So,
So those cables that got installed on our
Yes,
garage, were
yes.
you part of those decisions on where they were to be placed and how they got attached?
yeah, so the attempt is to initiate crack the beam so it gives it a chance to hinge. And then based on, well, Mark will set the charges and say, okay, I want a pole with earlier charge down below. And then try and pull those columns in, so.
But those are along the roadway.
Yeah,
so the whole
exactly. So
building
you can see he's
collapses in.
pulling that side of the building in, yeah. So everybody always asks me, what do I do? I'm a demolition engineer. And then they ask me, what does that mean? And I tell people, I'm the person who tells you how far you can saw through the tree branch before you need to stand on the other side of the tree branch. So what you'll see in this structure is it's been pre-weakened. And by pre-weakening a structure, it allows us to use less explosives or Mark and the CDI team to do the explosives. So my job is to assure that we have a continuous collapse mechanism, in other words, a logical path that this structure is going to come down. And number two, assure that it isn't going to come down until they set the explosives off. So the natural question is, why do we weaken the structure? How is it safe if we weakened it? If you think about it, there's absolutely no vehicles in this structure, right? So it was designed to carry what we call live load, or the load of the vehicles in the structure. We don't have that load. We've also have factors of safety built into our designs when we design structures to make sure that they're durable and account for inconsistencies. So when you take all of that into effect, when you're done with the design of the structure, you have a factor of safety of about 2, or the ability to take 100% additional weight of the structure and still be safe. That's roughly what you get in your traditional design. When we take all of the traffic load off of this structure, now we have a factor of safety of about 3, which means we could probably double the amount of vehicles in that structure and it would still be safe. So we take advantage of what we call that residual capacity, and we'll go in and we'll weaken those columns to bring it down to a more appropriate factor of safety without any traffic loading in it, but still maintain structural stability. In other words, it's safe to walk through, it's not gonna blow over in the wind, or it's not gonna collapse while they're doing their structural work. The reason we do that, again, is so that it reduces the amount of explosives used to create the collapse mechanism. And the reason that they want to reduce the amount of explosives is because it brings down what they call the air overpressure, or the blast wave as they set off these charges that will then weaken the columns and eventually lead to collapse. So the less explosives we use, in general, it's safer. We reduce the amount of overpressure. You protect windows, surrounding infrastructure, and things of that nature. By pre-weakening it, it requires less explosives. And again, it's fully engineered, so we've taken a look at the stability of this. We're not just going out there and sawing the bottom of the columns off, hoping that the structure stands up in place. And so we were just sharing a little bit of the information about the demolition industry. This is a perfect example of where your latest demolition design contractors and team are going, where it's a fully engineered demolition process. I would say right now in the industry, about 50% of all demolition that's being done is done under an engineered demolition approach. This project is in fact done that way, which provides the client, the public, the contractor, and all their workers just that much higher level of protection. So this is really, I think, the direction that you're going to see your demolition industry going, and it's nice to kind of see that level of safety and everything implemented in a successful project like this.
We had a group at the airport tour the facility, tour the garage last Wednesday, which was really cool. We saw some of what you instructed the workers to do, because every column had a V-notch chiseled into it, and rebar was cut.
That's right.
We call those rebar, those stirrups, is
Yes.
what holds the column. So every single column in the building
Yes.
had a chisel, I don't know where John is, cut out of the thing, and the rebar was cut. And it was really neat to see that. And you have cables inside the building so that when it, however it does its thing, it's going to fall in and not fall onto the adjacent road, because we wouldn't want that to happen. That would be bad if that happened.
That's right. That's right. So
So
your
hopefully
explosive.
we're not going to do that.
No, and your explosive contractor has carefully timed the delays so that the supporting column to that cable will go first. It'll pull on the cable, and then you'll set the charge off on the column that's supporting the cable, and that allows that thing to roll in, and you can kind of pull the edges of the structure in. So again, kind of trying to bring the envelope inward into a big pile.
So I heard also that this, I think, is 11.5 or 12-second implosion, so it's a slow one.
It's a slow one, yes.
So
yes.
why is it slow?
So there's a couple of reasons. First of all, you have a lot of utilities under this structure,
So
which
we
was
want it to
very
be
unique.
slow because we don't want all this stuff, all the load hitting at the same time, I guess.
That's exactly right. So we're timing the amount of debris that's going to actually impact the ground. And actually, by starting the delay in the middle of the structure, you'll hear Mark talk about hanging the structure. So we'll take the columns out, allow the deck to start to crack, and kind of try and support the middle of that structure, which allows us to take some of that energy out through deflection and kind of lower the middle of the structure much slower. And that basically reduces the amount of vibration that we'll put into the ground and its effects on the surrounding structure.
This is brilliant. So did we saw cut the floors?
No, you did not have to saw cut the floors.
Because I heard we were contemplating doing that. But
Yeah. The ramps themselves, we took out the shear walls alongside of the ramp, and then also in the core, elevator core structure, some of those walls were saw cut and weakened so that elevator core structure could come down easier.
So
Yes.
I saw the stat today on how many pounds of dynamite is
yes.
in the thing. Hang on, where'd that go? Here we go.
1,600.
So there's 1,600 pounds of dynamite.
Yes.
There's 15,000 lineal feet of detonation cord, and they drilled 1,400 holes. Now, you didn't have anything to do with that, right? Drilling the holes, where to drill, or did you help with any of that or not?
No, actually, Mark will design the
CDI,
pattern,
right?
right? So how
Design
much
pattern.
how much explosive per cubic yard of concrete is calculated on how they basically crack the concrete and remove that material. Yeah.
And so I think you said earlier that you expect there to be about a 20 to 50 foot pile of rubble once this thing is done.
Yeah, yeah. The middle of, because of the ramp structure and the ability to take out a certain amount of the columns in the ramp structure, the middle of the structure should be the highest. and then taper off to the edges. But if you think about it, you have 7 floors at about 3 feet,
Right.
with depth. So you're gonna have a pile at the edges of 25 to 30 feet roughly.
So what should we see start coming down first?
So you should see the middle of the structure start to move, and it's
The high level?
the
or
high levels to start to move, because we'll start bringing out the bottom column, so it'll start to sag in the middle. And then what Mark's done is the side here towards the red side, he's gonna roll that side in a little bit early to try and redirect the air. So as the air starts to move this direction, he's gonna
crazy.
roll the
Oh
edge
my
of the
God.
structure in a little bit early to try and keep that air
So,
blast from coming
From
this
coming
direction too
towards the
much.
building, right?
That's exactly right. And if you notice, he used chain link fence on the outside perimeter to push the air away from.
The fence does that.
That's exactly right. So the nice thing about the chain link fence is it catches debris, but it allows the air to move. So that's one of the nice things.
When will the
that's
big
in
shear tower, when is that supposed to go?
So
in the
that
sequence?
probably is about 2/3 of the way through. That's in delays, I think 4 through 8. So about 2/3 of the way through, you'll see the large shear tower kind of roll towards the middle.
That's because it's weakened to the north, and
That's
you
right.
want the thing to fall that way.
That's exactly right, yeah. And so it's important to note that you'll hear a series of bangs and nothing will move, right? And the first bangs that you will hear will be a sharp cracking sound. That is the detonation cord going off. So you can think of that as kind of lighting the fuse, and each fuse has a timer on it. So he's going to separate the charges using delays. And what that does again is it's kind of separating the pressure wave as the explosives go off, so that we don't set all the explosives off at once, which could create high air pressure and break windows. So he's controlling the amount of detonation going off at any single point in time. So you hear a series of sharp cracks, crack, 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 crack. That's really the det cord going off. And then you'll hear a more lower booming sound, a real deep sound. That is the dynamite going off, and that's when they're starting to explode the columns and move the concrete. So it probably will take up to 8 seconds or so before you actually hear the concrete going off. So don't be surprised if you hear bangs and nothing moves. That's a
Takes a while.
planned process.
So what are the horns that we're gonna hear at the front? Who know, do you know that?
A little bit about the horns. You're gonna get a 2-minute warning. So he'll give you a 2-minute warning. You'll hear some horns go off. That's just letting everybody know that they're getting ready to clear. Then you'll hear another set of horns 1 minute before the implosion. And then on the radio, he'll start the countdown. So you should hear an audible countdown. Sometimes he'll start at 10, and very interesting, sometimes you will not hear the number 5. He'll go 10, 9, 8, 7, 6. Then it'll go radio silence for a couple reasons. Number one, anybody can stop the situation at the last moment if they see something or somebody, heaven forbid, somebody was to penetrate the perimeter. You've got a clear radio channel. And then the second thing is sometimes the number 5 can sound like the word fire. So oftentimes he won't audibly use the number 5 in his countdown.
Really?
So just a little bit of interesting information there.
Yeah, that's pretty cool. Yeah, this is such a well orchestrated event that's been so clear to us as we watch this thing unfold over the last handful of months, and it's really neat to hear about all the really engineered information. So how does the ground vibrate through this? So what is that? Because the FA
Of course,
was
yes.
asking a lot of really
Yes.
good questions on that, and I think they were really impressed with your work, by the way, and I shared that with
Thank you.
with the team earlier, that this is the best implosion plan the FA's ever seen. And so we take a lot of pride in that, because that means we have the best working for us, which is really important.
Right.
So how does that vibration work in the ground?
So if you think about it, I think probably the most natural, similar type ground vibration would be like driving piles in the ground, right? Where we're impacting. So as we lower this material down, we're not lowering it all down at the same time. So by using delays, you're setting the middle of the structure down and then moving outward. So you're impacting the ground with a little bit of material at each pulse, right? So we're creating these kind of driven impacts into the ground, and then the soil that surrounds us affects how those pressure waves travel through the soil. So a lot of times I use an analogy. If you took a bowl of concrete and you hit the side of the bowl of concrete with a wooden spoon, you wouldn't see any surface waves. But if you take a bowl of Jell-O and you hit the side of that bowl of Jell-O with the same wooden spoon, you'll see the surface waves. So in general, you have water in your soil here. You have decent soil, but it's sandy soil right here. So we would expect that you're going to see some surface waves, and by controlling the amount of energy that we put into the ground and the distance that energy travels, we can predict not only the frequency of the wave, but the size of the wave going through the ground. And then compare that to the surrounding structure's ability to kind of tolerate vibration.
And that comes from the concrete falling.
That is correct.
So
That's actually
why
us.
slowing down the process of the concrete hitting the ground slower dissipates that, am I saying that right?
Absolutely.
The vibration through the ground. So if you did it
Yeah.
all at once,
Right.
just like that, well, then it would be much more significant. And
Exactly.
so the fact that you're going slow, and the FAA actually told us, Rich, that they liked it.
Yeah.
When you went from 14 seconds to, believe it or not, 11 seconds, they were really happy with that.
Yeah. Yeah. And
Because it helped them.
it's the way we're delivering the amount of energy to the ground. So it's just like felling a tree versus cutting the branches off and then trimming the tree at different levels. So that's essentially what we're doing, is we're not falling the whole tree in one event. We're actually trimming each branch, dropping each branch individually, and then cutting the trunk up in pieces so we can deliver the energy at a much lower level.
Got about 10 minutes before we go. Has anybody got any questions for the expert?
How loud is this gonna be?
So let's see. I think at 100 feet, at 100 feet, it should be around 130 decibels. So that's pretty loud. That's pretty loud. So I think about 70 to 80 decibels is probably your background noise that you'd hear. So louder than a very loud car going by. So you will definitely hear the noise. You will feel the energy come through in the pressure waves. So
And John's gonna have the radio if he didn't screw that up. Joe, so Joe's not gonna, so you're gonna be able to hear the whole countdown, right?
yeah,
So-
yeah, you should hear
So
the
we're gonna hear the
countdown.
countdown for
Yep.
that. And I think we should hear it up there, I think. I would think we'll hear
Dave's
it.
gonna open it, so
Yeah.
Dave's
Yeah.
gonna open his mic, so.
Oh, yeah,
Oh,
good.
yeah,
So we
good.
can, I think, I don't know that the windows are those the Mac Daddy windows up there, Rich, do we know?
Not sure.
I don't think so.
It looked like